Hello and welcome to my channel, Hardware.ai. In this video, I'm going to tell you about the newest and latest development kit and SoM for AIoT, Sipeed MAIX-II. Viewers of my channel and people who are following the developments in hardware for AI on the edge are familiar with MAIX-I board series. These are various K210 based boards. I have reviewed and made tutorials about them on my channel. K210 is a good, solid chip for performing vision and audio related tasks, machine learning tasks, in situations when power consumption and hardware footprint are of concern. It does have its own disadvantages though, namely low amount of RAM available, which constrains both the image resolution and the maximum size of the networks that can be run on the chip. If you are detecting or recognizing objects that are up close, there won't be an issue. But low resolution and model size limitation can impact performance when detecting smaller objects, for example, faces in the crowd from a distance. Likewise, proper OCR or open domain speech recognition are hard to implement when model size is limited to 2.5 or 3 megabytes. MAIX-II development board and SoM based on all-winner V831 chip aims to eliminate these problems and allow users to run larger models on higher resolution image input. The dev kit consists of a reference carrier board, a screen, a camera, and an SoM. Let's have a look at the specs of the new module and compare them to both old MAIX-I K210 core module and NVIDIA Jetson Nano 2 GB module specs. First of all, of course, one of the most important things is CPU, and we see that while MAIX-II offers an improvement over old MAIX-I had RISC-V dual-core CPU running at 400 MHz clock and can be overclocked to 600 MHz. New MAIX-II board features an ARM Cortex-A7 single-core processor that can run with the clock rates as high as 1000 MHz. At the same time, the CPU performance is still not as good as in Jetson Nano 2 GB version, which features ARM A57 CPU with clock rate of 1.43 GHz. Next, there is a hardware video encoder in MAIX-II, which will be really useful if you plan to transmit or save the video from device's camera. And one of the most important things for AI on the edge is the inference, machine learning inference accelerator. We see that MAIX-I or K210 based solutions had 0.23 TOPS KPU, which supported basic neural network operations, most common neural network operations such as convolutions, batch normalization, various activations and pooling. And for MAIX-II, it features NPU based on NVIDIA open source IP license from NVIDIA. It has the processing power of 0.2 TOPS and supports a larger array of neural network operations, including altwise and concatenation. We will see later in the software testing section that it allows the support for more common architectures of neural networks, such as ResNet. ResNet 18 wasn't possible to run on MAIX-I, but possible to run on MAIX-II. Then NVIDIA Jetson Nano has a GPU, 128-core NVIDIA Maxwell architecture GPU for inference accelerator. GPUs, unlike NPUs and KPUs, they are pretty much general purpose inference accelerator. MAIX-I has 8 megabytes of RAM, then MAIX-II has 64 megabytes, and NVIDIA Jetson Nano, since it's a full-fledged single board computer, it has 2 GB of low power DDR4. If you do not plan to run graphical user interface or desktop applications on MAIX-II and use it strictly for machine learning inference and probably receiving and sending data from the network, that amount of RAM is going to be enough for these applications. There is no storage, and for operating system SD card is used, pretty much the same way as an NVIDIA Jetson Nano or Raspberry Pi. And camera interface wise, it has 2-lane MIPI, which supports up to 1080 resolution video, 60 frames per second. It does compare favorably to MAIX-I, which only had DVP interface with relatively low throughput. 3 of these boards, they have the common interfaces such as SPI, Squared-C, and GPIO. Both NVIDIA Jetson Nano and MAIX-II have the capability to connect Ethernet cable. MAIX-II also has the built-in analog to digital converter, which none of other 2 boards have. That comes handy if you also have some analog sensors connected to your system. And the price, finally, of course, one of the most important aspects is the price. Both older MAIX-I and newer MAIX-II System on modules are priced at $7.9 and for NVIDIA Jetson Nano 2GB, I did not find a price for separate module on the internet, and the development kit cost $54.99. To summarize, MAIX-I K210 based was and still is good cheap alternative to Raspberry Pi if you only care about machine learning inference applications. And new MAIX-II is aiming to be a good cheap alternative to Jetson Nano. If you think this comparison is far-fetched, forget for a moment about all the things Raspberry Pi and Jetson Nano are good for as SBCs. Personal computer replacement, retro video game console, network, cloud attached storage, etc. And think about it purely from machine learning on the edge application standpoint. Raspberry Pi 4 can fork out 13 to 15 frames per second running mobile net 2 SSD with input resolution 300 by 300. That's maximum possible FPS currently with 64-bit OS and TensorFlow Lite threaded acceleration enabled. It will consume close to maximum power while performing the inference on all 4 cores, and the cheapest you can get it is $25 for SoM. MAIX-I, on the other hand, easily processes 320 to 240 video stream with mobile net object detection network at around 15 to 17 frames per second. And you can achieve better speeds if using YOLO V2 backbone network instead, and or switching to using C++ instead of MicroPython. No Raspberry Pi nor K210 boards are suitable for running larger networks, such as ResNet 18, or performing image processing, audio processing simultaneously. Here is where MAIX-II comes in. While its machine learning inference accelerator has the same processing speed, around 0.2 TOPS as K210 KPU, it has more RAM and thus able to easily run ResNet 18 or MobileNet plus speech transcription module at the same time. It also supports MIPI interface for image input and thus provides better resolution and picture quality, up to 1080p 60 frames per second for 2 lanes, thus eliminating 2 main limitations of K210 and bringing this new SoM and Devboard closer to the likes of NVIDIA Jetson series level. That is, again, if you only care about machine learning inference applications. Let's have a look at the Devboard and SoM. Here is Raspberry Pi 4 compute module and NVIDIA Jetson Nano SoM for size comparison. Let's take out one of these MAIX-II SoMs, so plastic bag. Well, MAIX-II looks tiny in comparison to these two, as we can see, and there are only a few noteworthy things on top of it. Namely, V831 system on chip right here near the center of the module, power supply IC at the top, connectors reserved for optional flash chip right here, and M2 key connector to the carrier board. Now let's take out one of these reference carrier boards with the system and module from the box. Basically, everything you can see in the box is the simple USB Type-C cable and the carrier board with system and module in bubble wrap paper. Now, unlike SoM, this thing is packed. It has 3-megapixel camera with 6mm focal length lens as a standard. On the back you can see 1.3-inch LCD screen, 2 USB Type-C connectors, SD card slot for placing SD card with system image, a microphone here in front, speaker, this is a speaker connected here, Wi-Fi module. Wi-Fi module is installed on the carrier board, 2 user configurable buttons and a reset button here on the top, and even 3-axis accelerometer also installed on the carrier board. Still, the reference carrier board is quite compact with its dimensions 48.9, 33.9 and 36.1. So if we place these 4 in a comparison, well, hardware is just plastic and silicon without software to make use of it. How is the situation on that front for MAIX-II? MAIX-II is meant to offer a relatively beginner-friendly Linux firmware based on OpenWRT, adapted for edge computing. Users can enjoy a more complete development environment and abundant software resources under Linux, unlike K210, which only could run MicroPython firmware or C++ compiled user code. As of moment, since MAIX-II is brand new, the software environment is pretty much work in progress. There is an OPKG package source for MAIX Linux provided. Python 3 8.5 is installed and default Python version for the system. And machine learning inference and hardware-related functions are to be integrated and accessible from MAIX-III pip package that you can easily download with pip install. There is also work to make Jupyter Notebook remote kernel to work with MAIX-II, allowing users to connect to board remotely using Jupyter Notebook and execute the code in notebooks. Since it's still early in development, I prepared for the worst when trying new MAIX-II board software. To my surprise, I did not encounter many bugs, although the functions are incomplete at this moment. I have flashed the latest firmware. Tools for flashing firmware are provided for both Linux and Windows, and then connected to the board over serial with Picacom on Linux. Edited WPI suppliant file to connect to Wi-Fi, then updated package index from OPKG. Then I simply executed pip install MAIXPy3 to install Python library for NPU and hardware function specific to the board. NPU functions are not ready to be used from Python at the moment, but I was able to run C++ compiled demo for ResNet 18 inference. Here is ResNet 18 network trained on ImageNet 1000 for image classification, running on MAIX-II board. If new MAIX board is even mildly popular, the product support will be on par with MAIX-I boards. Not stellar, but steady and long-term. Here I have to say, as a software developer myself, it doesn't matter how hard the developers try, the documentation will always be incomplete, and a lot of support actually comes from community. For instance, that is Raspberry Pi board's strongest side. So if you have basic Linux and Python development skills and are not afraid of little challenge when developing your machine learning on the edge applications, then new board might be just the right board for you. I'd love to hear from you what you think about this new board and SoM. Would you like to get one? Do you have any ideas in mind about the applications that can benefit from a board like this one that can run larger neural networks at affordable price? I'm eager to hear from you. Until the next time.